Hi there everybody, it's Chris van der Kerk here, Blue Rhino Safaris. One of the most common problems that we have when we're out on safari is a problem with power. The fridge are down, or the solar panels are not charging properly, the batteries are flashing red and little alarms going off in the evenings. Very common when you are out traveling on safari. And I wanted to go through the whole system with you, and it's going to be too long for one video. So in the first video I'm just going to do the basics. So let's look at the basics today of how these things work and what you should be looking out for. And let's start by the basics of what we have in a vehicle, and also the sizing of a typical vehicle. When you look at how big must your solar panels be, how big must your batteries be, what are you looking at? So we are going to start with a little bit of science and engineering. Now I have to say I specifically didn't study electrical engineering because I was scared of getting electrocuted, but I do understand it, and I'm going to give you the basic principles of electricity. So the first thing that we have to look at is energy. When we talk about power, we talk about energy, and energy expressed in joule. Now if you take joule per second, then you look at watts, and if you look at watts, then you have power. And power in the equation is always equated to P. In a typical 12 volt system, P, your power, is equal to your amps times your volts. So this is watts, this is amps, and this is volts. So to get the wattage of anything in my vehicle, I calculate it by multiplying amps with volts. So if I have a solar panel and it's a 200 watt solar panel, it would mean that if it's a 12 volt system, then the amps that I have in there would be 200 divided by 12, 16 amps. So the amps that I would see that runs through the line from the solar panel all the way through to the battery is 16 amps. Fairly straightforward to look at the principles of power. Now this works in all directions. You can use this formula in many different ways to calculate power and amps and things like that. So that's a very important formula to keep as your basic formula. Now when you start using things in parallel and things in series, then a few things changes, but that's for a different video altogether. So first thing to remember is that your energy, which could either be the sun, or it could be an alternator, or it could be another battery. Those forms of energy are expressed in joules. Joules per second give you watts. Watts is your power in your big equation. So let me wipe the board and we'll start with a typical system. Right, so as I've alluded already, in a vehicle like this is my 4x4. I've got my new Bundetec tent on the top. You'll see it's a lovely tent. In a vehicle like this, I have built in two power sources, and the one you know and the other one you didn't think of. The first power source is the alternator. That is your first power source. The second power source, which you did not think about, is your car's main battery. Now the principle here is, if I have a drain, let's say I have an empty battery, which sits in the back of my vehicle. Then if I connect a full battery, like my crank battery, to my secondary battery, then this secondary battery will drain the main battery. So this is my secondary one, this is my main battery, and if I connect the two, the full battery will give power to the dead battery, and that happens through the V. Volts. The easiest way to explain volts is to say, if I have a bucket over here and I have another bucket over here and they are connected with a pipe at the bottom, then if the liquid level is high on the first one and low on the second one, the potential difference is big and the flow is a lot quicker from this side to that side. Now if your level drops and it comes down a little bit and this one goes up a bit, the flow will reduce. So what you need to have when you're charging something is one that is empty and one that is full, a battery that is empty and a battery that is full. And if I have an empty battery, the full battery will send its power towards the empty one. But if my empty battery is full, then I have a problem, because now I don't have a natural flow of power from the one to the other. So what I need to do is I need to increase the level of my charging battery, and that I do with charging voltage that I raise. So instead of, let's say this is 12.8, it's full, this is 12.8, it's basically full. How can I get more charge into this battery? The only way I can do it is if I raise this to 13.6. So you'll always see that your charging side, your alternator, your battery charger, whatever you have charging, will always charge higher than 12.8 because it needs to create that additional height, the potential difference to push the power through to the charging or the charged battery. So when I say that you have two different sources to supply power, it is your alternator and your battery. Let's forget 220 volts. So if my secondary battery is fairly low, and let's say it's sitting at 50%, it means that if I leave the vehicle switched off and the alternator is out of play, that the main battery will push power into this one because of your 13.6, not 13.6, your 12.8 versus this one that might be sitting at 12.5 now. So you will have a flow of electricity. Now what does this mean? It means in real terms that if I'm at Monopools, and it happened with one of my guys in the group before, he connects the two batteries with the manual switch because his fridge is busy running low. So this is your car battery and this is your secondary battery. So his fridge is running low, and when he starts his vehicle in the morning, he flips a switch to connect the two batteries, and the car battery is now sending power over to the secondary battery. The alternator is replacing the car battery power, but very slowly. But the car battery is sending power to the secondary so quickly that after 20 minutes worth of driving, the car battery has dropped in voltage down to the level of the secondary battery. We stopped to take a picture of a crocodile in one of the rivers, and the vehicle wouldn't start because the secondary battery has drained the main battery. That's why I say you have two power sources. You have a battery. If you flip a switch and you connect the main battery with the secondary battery, this main battery will lose its power. Then you have an alternator. That is your second power source. Now, contrary to popular belief, an alternator is not the best form of energy. If an alternator runs, then again it lifts the power up to 13.6, 13.8 volts, something like that, and it then depends on the level of the low battery as to how much power goes through. So the amps that will go through will be maybe 25 amps running from your car battery, from the alternator to your system. And if you do that at 13 volts, you can say 25 amps times 13 volts, just to give you an idea. $325 watts. 3 to 5. So if you use this equation, then it means that the alternator is only pushing through 325 watts. And that's not a lot. It is enough, but it's not a lot. So it doesn't solve all your problems. If you start your vehicle in the morning, and this is something that I see quite regularly, if you start your vehicle in the morning or in the evening, let's say you've been standing at Serengeti for a few days, or not that we do that, but you've been standing at a campsite, and you recognize that your secondary battery is running down, and you're sitting with just 3 red lights at the bottom. You say, oh, I have to do something about this. Let's run the car for half an hour. So if you run the car for half an hour, you are engaging the alternator, but you are also engaging your car's main battery. Now the alternator in that half an hour will only give you 150 watts. That's all that you're going to get from the alternator. The rest of the power that goes into your second battery will come from your battery itself. So the battery will push through a bunch of power. Let's say the battery pushes through 20 amps. 20 amps times 30, or another 25. Yeah, let's do that. That's 150 watt. So you've only scored 300 watts over that hour that you ran the vehicle. And the alternator did half of the work, and the battery did the other half of the work. So after an hour, if you wanted to start your vehicle, suddenly your main battery doesn't want to start, because your main battery has now been drained. And the alternator did not have enough time to provide the energy to replace what has been moved out. Alright, so let's look at an example of the whole system. Let's say I have a secondary battery in my vehicle, and that battery, this is my main, this is my secondary. The main battery is, in typical vehicles, 80 amp hour battery. Second battery, what everybody knows, 105 amp hours. Now, what is an amp hour? Basically, an amp hour is, if in my equation I take the amps for 1 hour, that will give me 1 amp hour. So if I pump 20 amps for 1 hour, then I have produced, I could fill up, not fill up, but I've produced in battery life 20 amp hours. So to take a 105, if I run 100 amps, 20 amps, sorry, on a 105, and this 105 is at 50%, it means that, or the 105 is full, it means I can drop 20 amp hours for 2 hours to get down to 60 amp hours, which is 60% full, and that's the limit. No further on a normal lead acid battery. So I can do two 20 amp hour stints, packages, to drain this battery down to 60%. Now, how do I get that? A typical fridge runs at about 3.5 amps if it draws current. Now, the 3.5 amps is when the motor is running on a typical fridge. The efficiency of the fridge plays a role in how much power it uses. So the better insulated it is, the less it will run. The worse insulated fridges will run for longer. So if I have just a little thin plastic skin, obviously the compressor will run a lot longer than if I have nice thick polystyrene sides that protects the cold inside. So the length of time that the fridge will run will give me my amp hours. Now, the current that it draws when the motor is running is 3.5 amps. So if a fridge was running full out, it would be 3.5 amps per hour that it draws. Now 3.5 amps per hour over a 24-hour cycle will give you 3.5 times 24, 84 amp hour. Now 84 amp hour on a 105 will bring it down to 20%, which is way too low. So if I stop at 50 amp hours, then it'll be probably about 16 hours maximum that I can run the fridge at full pace, 3.5 amps. When does the fridge run at its full pace for continuous time? If you set it down to its minimum, and it can never switch off because the thermostat never has time to disengage, it will just continuously run, and it will run for 16 hours. If my fridge will run for half of the time, so I'm managing it so that my fridge runs only for half an hour per hour. So every 30 minutes of the hour the fridge is on, 30 minutes of the hour the fridge is off. You can hear it switching on, switching off, and you put a stopwatch to it and you compare the two times. You can see that 3.5 amps over half an hour gives you over half an hour will give you 1.75 amps per hour. Now that's a lot better than 3.5. So if I can have my fridge switch off half of the time and run half of the time, then I will save some energy. But it means the fridge might be a little bit warmer. So I bring the temperature from minus 15 on a freezer to minus 7, and I might just achieve this. So this is all fluid, and it all depends on temperatures outside and things like that. So let's say my fridge runs half the time. I've managed it so that it runs for 30 minutes and it's off for 30 minutes. That gives me 1.75 amp hours on my fridge. Now if I take my 105 battery and I say I don't want to run it less than 60%, it gives me 40 amp hours roughly. So I have 40 amp hours to work with at 1.75, which my fridge will draw, and that will give 40 divided by 1.75 is 22.8 hours. Now what does that mean? 22.8 hours means that if I don't give any charge to this battery, the secondary battery, then my fridge will run for 22.8 hours, and then I have to switch it off because I've then reached my 60% limit. So 22.8 is not too bad, because if I drive every day, I can replenish that. So that will work for me, not a problem. But how do I replenish the power that I've taken out? I have to put back 40 amp hours back into the system. Now 40 amp hours, to get that into a solar panel, will be, let's say you have a 100-watt panel. Then looking at this equation of yours, your 40 is equal to 13. Now in any day you have 6 hours of sun in South Africa typically. So 6 hours of sun. You have efficiency with a horizontal panel. You have an efficiency of 70%. So 70% is 0.7. And then I'm looking at my solar panel. So 40 times 13. Let me do this, yeah. So 40 times 13 is not that much. It's 520, and divide that by 0.7, which is your efficiency, divided by the hours, means you need a 123 watt panel. So if I'm running a fridge, half an hour of every hour, it will last me almost 24-hour cycle, which is more or less what I'm looking at. I will drain 105 amp hour by 40 amps, so I'll bring the battery down to 60%. If I want to replenish it with a solar panel for 6 hours in the day at a 70% efficiency for a horizontal panel, I will replenish my 40 amps at 13 volts with a panel 123 watts. And that is basically how you would look at this. Now, if I was running more fridges, then this equation will just change accordingly. So if you had 2 fridges, then this will go up and it will basically double. It will give you 250 watt panel to run. But then your 105 would not be good enough anymore. You will actually need to change your amount of batteries. So that's the basic layout of a system. So remember, when you drain your secondary battery, then you have your alternator and your main battery that provides power to this one. Be careful not to drain your main battery. I hope this makes a little bit of sense. If there's any questions, let me know and we can see how we can solve it. Cheers.